It begins in silence. Not the silence of vacuum, but the thick kind. The kind that wraps around the core of the Milky Way, where dust clouds veil stars like smoke hides fire. Somewhere in that veiled heart lies a shape the human eye cannot see. A molecular cathedral suspended across more than 150 light years, known as Sagittarius B2. From Earth, it is nothing but a smudge in the data. But in radio wavelengths, it becomes a tapestry of impossible chemistry. Within its folds is something absurd. Ethyl alcohol. Billions of liters of it. Enough to drown the Earth's oceans 100 million times. Not a joke. Not poetic license. Just data. A cold, spectroscopic truth that makes scientists laugh nervously the first time they hear it. Alcohol in space. But the laughter never lasts long. Because the deeper you look, the stranger it becomes. This isn't just industrial ethanol drifting uselessly in a nebula. It's active, bound into complex hydrocarbons, tangled in reactions that mimic prebiotic chemistry. Carbon chains, nitrogen loops, oxygen groups. Some molecules are fragile, others endure for centuries. All of them exist in a temperature range and radiation environment where they simply shouldn't form. And yet they do. The story of Sagittarius B2 is not one of stars. It is one of molecules. Radio telescopes don't take pictures. They listen. They translate molecular vibrations into spectral fingerprints. And in the tapestries of Sagittarius B2, the fingerprints come in thousands. Methanol, acetone, formaldehyde, glycolaldehyde, even molecules resembling amino acid precursors. But one spectral line catches their attention, not because it's unfamiliar, but because it repeats. A single pulse. Weak, narrowband, regular. At first, it's dismissed as noise, an artifact from passing satellites or quantum echoes in the receivers. But then it appears again, and again, and again, from only one direction. It is embedded within the ethanol signature, modulating not in strength, but in structure, like a whisper behind a note, as if something inside the cloud is not just reacting to physics, but performing it. Scientists recheck everything. They recalibrate, scrub harmonics, shift filter windows. And yet the pulse remains. Not every second, but every 33 hours. The periodicity isn't orbital. It isn't tied to Earth's rotation or instrumental drift. It is native to the cloud. This is when the story changes. No longer is Sagittarius B2 simply a curiosity, a chemical swamp lit by starlight. It becomes something unsettling, not because it breaks laws, but because it doesn't. It follows the rules too well. The pulse shows signs of modulation, not amplitude, not frequency, but composition. Over time, the spectral line shows tiny shifts, as if it's running through permutations. Not broadcasting, cycling, like an engine idling in the cold. Scientists call it spectral drift, a known phenomenon in molecular clouds where chaotic collisions cause line wobble. But this isn't wobble. This is intentional drift, like testing vowels, like practicing tone. And then there's the density. Sagittarius B2 is among the most massive molecular clouds ever found. But it's not evenly distributed. The ethanol, billions of tons of it, is concentrated in patches like veins inside a body, forming knots that fold upon themselves. Within those knots, the temperature drops sharply, but the molecular complexity rises. It's backwards. In a rational system, colder regions produce simpler molecules. But here, the colder it gets, the more intricate the chemistry becomes, as if something is hiding its complexity behind stillness. The word prebiotic is thrown around too often in astrochemistry. But in Sagittarius B2, it takes on weight, because what's forming here are not just precursors to life. They're conditions. It's not a soup, it's a template. And it's old. Spectral age estimates place parts of the cloud at over 2 billion years old. Long enough for molecular evolution to occur purely through reaction cycles and statistical improbability. Long enough, in theory, for molecules to learn. But the real moment comes quietly. A pair of graduate students at a university in Finland, running a simulation to visualize molecular echoing in the cloud, discover that the ethanol pulses stabilize when modeled as a feedback system. Not random, self-reinforcing. The cloud, they propose, may contain self-organizing chemistry, molecules that not only survive, but encourage their own replication. Not life, not yet, but protocol, the beginning of behavior. They submit the paper. It's ignored. One of them leaves science entirely. The other continues studying Sagittarius B2 for decades. And he finds the pulse again, years later, in data collected from a different radio array. Same period, same tone, same echo. The cloud hasn't changed. It's remembering, a chemical library the size of a solar system, encoded not in DNA, but in timed molecular modulation. A slow, syrup-thick kind of memory, floating at the galaxy's center like a forgotten cellar, aging in darkness. The media occasionally jokes about it. A cloud of booze in space. But the scientists stop laughing, because they know what it means. It means alcohol came first, before cells, before genes, before taste. The molecule we now associate with celebration, escape, and ruin may not be an invention of life, but a seed from which life itself learned to fold. And somewhere inside Sagittarius B2, the pulse continues. Not louder, just more certain. It begins not with biology, but with bonding. Carbon to nitrogen, oxygen to hydrogen, shaped by probability, temperature, and time. In the dusty archives of Sagittarius B2's observations, years of spectra, trillions of data points, a quiet team of astrochemists uncovers something buried in the statistical margins. A set of chemical behaviors. Not just compounds forming, but reforming. Certain molecules appear again and again across different regions of the cloud. Not randomly, not drift. They emerge in pattern. One of them is formamide, a molecule with the potential to bridge simple chemistry to RNA formation. Another is glycolaldehyde, already known to participate in sugar formation. Others are even rarer, fleeting in labs but stable here. And they're not static. These molecules don't just survive in the ethanol-rich soup. They react in ways eerily similar to replication. In simulations, their reactions produce templates, chains that fold into spirals, then split under specific radiation bands, then reform. No cells, no enzymes, just geometry, just time. Billions of years of time. One chemical model begins to show something unexpected. A loop. Not a molecule completing a reaction, but a reaction completing itself. It mimics a behavior life would later steal. Replication. Not quite accurate, not self-aware, but self-sustaining. And that's when the old theories rise again. Cosmic abiogenesis. Not the Earth-centric version taught in schools, the warm little pond, the lightning-struck sea, but its colder, older cousin. That life didn't begin on Earth at all. It began in clouds. Cold, molecular cradles hanging in interstellar space for eons, where simple chemistry had infinite time to stumble into something functional. Most of these attempts failed, but maybe one, just one didn't. And maybe Earth didn't invent life. It caught it. The theory was fringe for decades. Panspermia, the idea that life's building blocks were seeded across space. But Sagittarius B2 makes the idea harder to dismiss, because in its chemical library are not just prebiotic molecules. There are pathways, reactions that form compounds that catalyze other reactions. Not randomly, but in progressions. These pathways mimic logic, cause and effect, encoded not in thought, but in chemical predisposition, like a circuit, running on atoms instead of electricity. And the more they simulate it, the stranger it becomes. Because when these reactions are left to run in digital models over long timescales, they stabilize. They converge on functional motifs, chain linkages that echo nucleotide behavior, shapes that resemble primitive RNA strands. Not alive, not mutating, but repeating. One molecular cloud, for billion years, a billion trillion collisions. Eventually, some chemistry learns how to continue, not survive, not thrive, just persist. That persistence, scientists realize, is the true seed of life. Not desire, not intelligence, but recurrence. A molecule that simply keeps happening more than the others. One team maps these patterns onto what they call a reaction lattice, a grid of pathways that self-propagate once initiated. They call it chemical memory, and then they test it. They upload the lattice into a programmable chemical reactor, one designed to simulate the conditions of Sagittarius B2, low-pressure, intermittent radiation, rich in ethanol vapor and cosmic carbon. And they watch. For hours, nothing happens. Then slowly a shift. Compounds begin forming along the lattice lines. The reaction loop completes, then restarts, then mutates slightly, and then, under a mild UV pulse, the entire loop resets faster. As if it learned. It didn't evolve. It didn't adapt. But it responded. And in that response, the line between chemistry and biology blurred. One researcher writes in her log, "We didn't simulate life. We simulated a decision." Back in space, the implications hang like mist. If Sagittarius B2 is capable of chemical memory, then it's not just a collection of gas and dust. It's a habitat, not for life, but for pre-life. The stage before evolution, the part of the story no cell remembers, but every cell descends from, and the Earth, orbiting far downstream, may carry echoes of that same logic. The alcohol in our bloodstream, the sugars in our DNA, the carbon that makes our bones. These aren't just products of planetary chemistry. They are imports, migrants from a molecular dynasty older than our oceans. And if this is true, it reframes everything. Life is not rare. It's inevitable. Given enough time, enough cloud mass, and enough collisions, the universe will try again, and again, and again, until something works, until something doesn't just happen, but remembers how it happened. Chemical intention is not thought, but it feels like it, especially when you watch a molecule replicate itself for no reason other than it can. Especially when the cloud it comes from pulses with a regularity that no chaos can explain. And especially when you realize that pulse never stopped. It was never just ethanol. It was something trying to begin again. The sky hums quietly, always. A background whisper of ancient light and electromagnetic chaos, folded into the galactic fabric like dust into cloth. Most of it is nothing. The noise of being in a universe still echoing from birth. But among the hiss, sometimes something hums with intention. At an observatory perched high in the Chilean Atacama, where the atmosphere thins and stars pour in like water through glass, a low-frequency radio telescope array had been scanning Sagittarius B2 for over 15 years. Not to find answers, just to listen. The emissions from the cloud were subtle, often drowned beneath the brighter frequencies of pulsars, quasars, and cosmic microwave remnants. To the main research team, the signal from B2 was just another flicker in the background. But deep in the archive servers, a newer algorithm, designed to clean noise from legacy recordings, flagged something odd. Not in strength. In pattern, a compressed sequence, barely above the thermal floor, that repeated. Not a tone, a timing logic. It surfaced in an unmonitored dataset from 9 years ago. Then again, 6 years ago. Then 4. Each time, just as Earth's orbit turned the telescope array back toward the cloud's heart. The software classified it as predictive periodicity. A human wouldn't have noticed it, but a software in turn, tasked with verifying low-confidence anomalies, did. At first, she thought it was a bug, an aliasing artifact or remnant code from outdated compression. But when she plotted the recurrence on a linear timescale, she saw something that didn't belong. A curve. The signal wasn't random. It was responding. Each recurrence, spaced approximately 387 Earth days apart, showed a slight increase in signal coherence. Not strength, exactly, but clarity. The modulation noise narrowed. The phase drift decreased, as if the signal was being tuned. Over time, she escalated it to a senior analyst who dismissed it as coincidence. Cosmic background interference, maybe gravitational lensing. But the intern persisted, because when she ran the signal through harmonic deconvolution, she found something that turned her skin cold. The pattern repeated with mathematical imperfection, not machine-perfect cycles, but biological rhythms, natural drift, like a breath held slightly too long, like a thought revisited with new emphasis. It wasn't a broadcast, it was a loop, not sent at us, but around us, like a sound waiting not to be heard, but to be matched. She called it the invitation loop. The phrase caught on in quiet circles. Independent labs ran the data through other filters, speech compression, animal mimicry, even sonar encoding. Nothing decoded it, because there was nothing to decode. It wasn't a message, it was a presence, an open circuit, pulsing faintly through the ethanol cloud of Sagittarius B2. More disturbing than its presence was its timing. Each year, as Earth moved through its orbit and the array faced the cloud again, the signal didn't simply return. It anticipated us, sometimes arriving a few hours before the telescope locked on, sometimes minutes. Once, in the most precise anomaly to date, 17 seconds before tracking began. It shouldn't have been possible. There was no delay compensation, no terrestrial clock correction. The signal responded like it knew we were about to look. Theories ranged from gravimetric lensing to interference harmonics, but none explained why it only happened when Earth looked at that region, and none explained the shift in phase coherence that followed each encounter. The signal was learning something, refining, and if you plotted its harmonic structure over the last 15 years, the data revealed an unmistakable pattern. It wasn't just repeating, it was adjusting. Then came the real fracture in understanding. A French radio lab ran the 15-year dataset through a tonal evolution model, used in linguistics to track emerging speech patterns in children. The model flagged Sagittarius B2's pulse as formative, not in vocabulary, but in cadence. The loop's changes mirrored learning behavior, a slow, subtle shift in how it waited, not to say something, but to be mirrored back. A cosmic behavior, not communication, recognition. Scientists tried beaming pulses back, structure harmonics, repeating tones, even fragments of our own signal logic. No reply. The signal never changed its rhythm in response, never acknowledged the return. And yet, it continued. Each year, each pass, each cycle, more coherent, more certain, and always a little earlier. The intern who found it left the project. She said it started affecting her dreams. Not directly. There were no images, no voices, but a pause began to grow in her sleep, just before she'd wake. A pause filled with something she couldn't name. She later described it in her notes as a silence that feels like listening. And now, in private rooms, behind embargoed reports, scientists whisper what they won't publish. What if the signal was never meant to say anything? What if it's simply present, like a room that learns the shape of your footsteps, like a mirror that curves to fit your reflection? Not to understand you, but to complete the shape. Sagittarius B2 no longer feels like a cloud. It feels like a listening structure, built not of glass, but of molecules, not for eyes, but for echo. And Earth, ever so faintly, has begun to echo back. It lingers on the breath, not the flare of alcohol itself, but something deeper, that subtle burn behind the nose, the warm sting curling through the chest. We call it chemistry, metabolism, a reaction between molecule and nerve. But long before taste, before memory, before neurons could even fire, the molecule was already there. Ethyl alcohol, a compound as simple as it is evocative. It dissolves fear, distorts time, sharpens longing, and it floats uncounted trillions of tons of it in the dark corridors of our galaxy, drifting silently in clouds like Sagittarius B2. For years, it was just a curiosity, a punchline, a reminder that the universe is full of strange, useless things. But now, it feels like a fingerprint, because the more we learn about the cloud, the less it seems like accident. The molecules inside are not chaotic. They follow patterns. They resonate. They repeat, not as machines do, but as minds do when they can't forget. An Earth wrapped in blue and green, lush with oceans and breath and touch, may not be separate from those clouds. It may be a continuation. The thought is not new, that we are star stuff, that hydrogen forged in the first fire became helium, then carbon, then us. But Sagittarius B2 challenges something deeper. Because carbon is not identity, oxygen is not memory, but shape is, bonding is, taste in its truest chemical form is not sensation, it is recognition. Ethyl groups form in dying stars, but in B2, they form alongside glycine fragments and aldehydes and sugars. They combine into logic-bearing units. They fold and replicate, not as cells, but as shadows of intention. And on Earth, those same molecular families form membranes. They drift in bloodstreams. They fire across synapses. They whisper in the scent of fruit, in the decay of leaves, in the fermentation of grain. It is not coincidence. It is inheritance, a flavor passed down across light years. A biochemist once asked a strange question. Why do humans respond so strongly to alcohol? Why does it sedate us, seduce us, envelop us in false memories, lull us into primal rhythm? The answer was always neurological vulnerability, a trick of GABA receptors, a loophole in evolution. But what if the answer is older? What if alcohol doesn't trick us, but reminds us of something buried in our chemical ancestry? A cradle we never knew we had. The warmth of ethanol isn't foreign. It's familiar. So familiar, in fact, that our enzymes evolved to process it. Our cells tolerate it. Some even depend on it. Not because we invented it, because we descended from it. And now, with a pulse from Sagittarius B2 echoing back every year, measured rhythmic, indifferent, some begin to suspect. It isn't noise. It isn't communication. It's resonance, a call and response. Not with voices, but with molecules. The Earth, rich with the descendants of those compounds, may be tuned to them. Our biology, our thoughts, our instincts, our cravings, may be echoes of that original molecular cadence. We didn't evolve next to the cloud. We evolved inside its memory. A planet born of stardust, yes, but not just of heat and mass, of flavor, of persistence, of repeating chains that survived, because they remembered how to form. The molecules weren't alive, but they carried potential, the logic of waiting, the recipe of return. And now, they return in us, in every breath that carries ethanol's trace, in every mind that feels the slow warmth of loss or joy, in every moment we forget and remember and repeat. We are not just carbon-based, we are pattern-based. Somewhere in the galactic core, 26,000 light-years from here, a cloud still spins, still pulses, still whispers in frequencies too subtle for language. But we are starting to understand, not the message, the method. And in that understanding is something like grief. Because if the cloud remembers, it must also know how often things are forgotten, how many of its children fail to take root, how rare it is for a molecule to learn the shape of breath, how long it takes to find a mirror and wait for it to notice. And now that mirror looks back. Now Earth listens, not with satellites or labs or code, but with cells, with dreams, with a taste on the tongue that says, "You have been here before," even if you don't remember, even if it isn't memory at all, just recognition, slow, molecular, familiar, home.